Okay. Speed.
At first, they were little worm-like blobs. It was hard to see, but we saw a universe of possibilities. Of course, many things went wrong. A welding machine exploded, nozzles got stuck, and the robot got disoriented. But then, they became long lines, complex curves, and double-curved oval tubes. It was like drawing in midair. And after endless testing, we were able to speed up the process and produce this complex sculpture of lines. And now, we are ready for the ultimate poster project, to test all facets of this highly promising printing technology. A large-scale object that is functional and meaningful. We are going to print the steel bridge in Amsterdam.
Backyard playhouses are commonplace in Minnesota. Concrete castles, well, not so much.
It was my dream to build someday a castle.
Andrei Rudenko is a contractor with a passion for computers and architecture and a mind for invention.
So extruder supposed to be right here.
Captivated by 3D printers, Andrei designed his own. Using steel rails, chains, and motors, he built an extruder that spits out layers of concrete in whatever pattern he programs.
Actually, it's almost the same like a regular printer, but much bigger size.
To extrude the concrete, he had to get the mix just right. After the layered walls of the castle were complete, pieces of the turrets were printed out and stacked into place.
Just got an idea about I can use it to print houses.
And he's dreaming even bigger, scaling up the size to, yes, build something to live in.
It's not just some days. I can print house like in a couple months.
This king of his own castle is setting sights on the real world.
I was so happy to finish it. Probably I wouldn't do it one more time.
Chinese company Winsung says it can build a house using 3D printer technology. The technology behind the 3D printers that can print anything from parts for your car to parts for your body is pretty much the same as that that's used in your everyday inkjet printer. Winsung has now taken that technology to a new level. Its new massive 22-foot tall, 30-foot wide, and 490-foot long printer can print out an amazing 10 homes in a day. The 3D house printer has been in development for nearly 12 years using off-the-shelf technology from similar large-scale printers bought from overseas suppliers. The ink that it uses is a combination of special cement and glass fiber. The company even says to help keep it green, it can use scrap material left over from construction and mining sites. The walls and other components for homes are printed in the Suzhou facility just outside Shanghai and then later shipped to the factory in Shanghai for assembly. The development cost of the huge 3D printer is only $3.2 million US, and that translates directly into savings for the future homeowner. A 2,100 square foot house can be printed for around $5,000 US. It will take some time before building codes are implemented that allow for the printing of homes on a large scale. For now, the technology is new, and as with any new technology, it will take some time before it matures. Winsung says the scalability of manufacturing using this technology is limitless. If you can build a home, you can build a building. And who knows, maybe even bridges and skyscrapers. The first uses for this technology could be to build homes in areas that otherwise could not afford them or need to be rebuilt quickly. Imagine having 10 homes built each day by just one machine in an area affected by a major natural disaster or even war. I'm Mike Turber, reporting for OffGridWorld.com.
The 3D printed flute is a research project in the MIT Media Lab. Our goal was to create a flute using 3D printing technologies, a flute that is compatible with a traditional concert flute both acoustically and ergonomically. This flute is composed from several materials. A rigid material was selected for the flute's body, a different one for the mouthpiece, and a soft material for sealing the air properly. Only springs were added manually later. This project was fabricated with the Object Connex machine, which can print multiple materials in a single build. The overall process took around 15 hours, creating 4 separate parts that then were assembled to a working instrument. The first step of the process started with a CAD software design, building a digital model of the flute in the computer and redesigning its mechanism to fit the abilities of the 3D printer. Then, the design was sent to the Connex machine with simultaneous jets of multiple model materials to create composite digital materials on the fly. The printed object is covered with support material that need to be removed manually using water pressure.
Yeah. You kind of want the space to be distinct between the keys.
This is a work in progress, and our printed flute is not a perfect instrument yet.
So I think the mouthpiece is good. This edge should be like slightly sharper. That edge right there, so that you can feel it with the delicate skin of your lip. The proportions feel correct, and along like the distance of the fingers, that's fine. So it sounds perfect in terms of the acoustics. If you just fix some of the keys matching together, I think this thing will feel good. This part right here, it feels like it would wear out really fast. Like maybe in a couple days.
Yeah.
But if you print it thicker,
Some keys did not close properly, constraining the hands of the player from moving freely up and down the keys.
this one feels pretty good. Right there, feel that?
Yeah.
You can get those subtle ornamentations.
While traditional techniques may continue being superior to 3D printed ones in the process of fabricating traditional instruments, the new technologies can enable new designs that are not doable otherwise and may help to develop new acoustic experiences.
Coming up, we're going to turn our failed prints into recycled filament. Hey everybody, welcome to another 3D Thursday. I'm Noah. And I'm Pedro. And today we're going to break down some failed prints, fire up the Filabot, and make some recycled filament. That's right, it's all about sustainable 3D printing and recycling old failed prints to make new filament, saves you time and reduces waste. Let's check it out.
3D printing a whole lot usually means a lot of prototyping. Before we can start recycling, we'll need to sort our parts by color and material. Using these shoe dividers, we can keep the parts separated and organized. So how much does my print actually cost? To find that out, we'll use a simple equation. We'll multiply the cost of the filament by the weight of the part and then divide by 1,000 to get our print cost. So if AdaBot weighs 110 grams, then it only costs $4 in filament to print. And that's pretty good to know. Filament extruders like the Filabot grind plastic mulch and extrude it out, making recycled filament.
Before we can start, we'll need to break down the parts. We can crush them down with a rubber mallet and use a canvas bag to keep pieces from going everywhere. Using an electric wood chipper, we can fit the crushed parts using a feeder and turn them into mulch. Next, we'll need to sift through the mulch and remove the bigger chunks. We'll gather up the scrap so that we can feed it into the filament recycler. Temperature and extrusion settings vary from material. Our guide on the Adafruit Learning System has all the details. To get a consistent filament diameter, we'll need to let the filament extrude for a while. We'll need to have a good amount of recycled mulch for your first batch. Guide the filament down to the floor and use a fan to cool down the plastic as it coils. Once you have extruded a good amount of filament, use a caliper to measure the consistency of the filament diameter. In the next project, we'll find out how well the recycled filament prints and compare it to manufactured filament. Thanks so much for watching, and don't forget to like, share, and subscribe for more 3D printer projects from Adafruit.